Good morning everyone, welcome to today's worked exam answer video. Today I am taking a look at a fairly long 8 marker. It's an A-level question from an AQA paper looking at the production of ethanol via fermentation. We are essentially thinking of the advantages of producing ethanol via fermentation as opposed to the direct hydration of ethene. And then we're having a think about some equations to show the fermentation process and also the combustion of the ethanol once it's been produced. Because when we're thinking about making ethanol via fermentation, in a lot of instances, it's to use the ethanol as a biofuel. Now, this 8 marker was from a bit of an older paper. Nowadays, you will get longer questions, but certainly non-mathematical questions will be generally capped at 6 marks. I don't think in the recent papers I've seen any questions be more than 6 marks that are not calculations. Some of those 6 markers might be levelled answers, some of them might not be. But when we go through this question together now, you will see that a lot of what you are being asked to do is very kind of carefully stated in the question. So as you go through it, you can think, oh, I'll get a mark for that, a mark for that, a mark for that, and so on and so forth. So it's not quite as daunting as it may appear right now to have a look at. Those of you doing GCSE, either the AQA spec or off the top of my head, the Edexcel iGCSE Triple Award spec, will also need to know some components of this. Not all of it, but certainly the conditions that are required for fermentation, absolutely. Thinking about why that temperature is the optimum temperature, absolutely. It'll be the latter bit with the advantages that you won't need, but then actually writing the equations for the production of ethanol and the complete combustion of ethanol, you might get asked as well. So GCSE students, this question is nearly all for you as well. So, as I've already said, ethanol can be produced commercially by fermentation of aqueous glucose, glucose being C6H12O6. So we've got to state 2 conditions other than temperature which are necessary for fermentation. Explain why neither a low temperature nor a high temperature is suitable for this reaction. So that's why we can't give the condition of temperature, because they've basically told us it can't be low and it can't be high. Then we've got to give 2 advantages of this method of production over that by the direct hydration of ethene. GCSE students, you will still need to know that we can make ethanol from ethene and the conditions for that, but we wouldn't be thinking about advantages and disadvantages. It could be a suggested question, I suppose, but it's not something that I have seen. And then finally, write an equation for the production of ethanol by fermentation and an equation for the complete combustion of the ethanol. So we'll go in order. So first of all, we've got 2 conditions which are necessary for fermentation. So number 1, we need there to be some yeast, because the yeast enzymes are the catalyst for the reaction. And the second really key condition is there needs to be an absence of air, or it needs to be anaerobic. Either's fine. And the reason for that, twofold. One, if we've got glucose and then there's oxygen present, the glucose will respire and we'll get aerobic respiration, making water and carbon dioxide. No ethanol would be made. Secondly, assuming there was then some ethanol that somehow did get made, the presence of oxygen would then oxidize the ethanol into ethanoic acid, which is a carboxylic acid. So we're not then going to have any ethanol either. So the absence of air is really important. Now, in terms of temperature, it's good to remember that the temperature will be somewhere around 35 degrees Celsius. And I know they've said you're not going to get a mark for stating the condition, but when they say low temperature, we're thinking sort of 20-ish. High temperature, kind of, 50, 60, 70, that sort of idea. And that links in with the enzymes that we're using from the yeast as our catalyst. Enzymes at low temperature are not activated. They don't get denatured like they do at high temperature, which is where the tertiary structure of the protein, which the enzyme is, unravels. And if it doesn't have that 3D structure, it's not going to have its active site. It's not going to be able to work as a catalyst anymore. So at low temperatures, it's not about it being denatured, but it's just not active. It's kind of deactivated by low temperatures. So I'm going to put 3 as 35 degrees Celsius, and I'll put that in brackets because we didn't need to state that. We weren't allowed to state the temperature, but I'm going to use that to help me to say if the temperature is too low, the enzymes won't be active, slash won't work effectively. And then if the temperature is too high, the enzyme will be denatured, which will hopefully be a word that you're familiar with in biology for those of you at GCSE and even at A level. If you're not doing A level biology, you probably will be familiar with that term. So that's the temperature bit done. So we've kind of got 1, 2, either 3 or 4 marks now. Give 2 advantages of this method of production over that by the direct hydration of ethene. So when we're thinking about using ethene to make ethanol, the ethene fundamentally comes from crude oil. So we would take our crude oil, we'd do fractional distillation, we would then take the surplus of the longer chain hydrocarbons, crack them into shorter chain hydrocarbons, and we'd get shorter chain alkanes and some alkenes being made, and then we can take the alkenes from there and do many things with them, including turning them into an alcohol. That's obviously bad because crude oil is a finite resource. It's going to run out. We're already getting to the stage where, yeah, it's getting a bit tense thinking about what we're going to do when the oil does run out, trying to get all the last scraps of it out of the earth kind of thing. So a major advantage of fermentation, the glucose comes from like sugarcane plants. So it's very sustainable. We can grow more sugarcane plants. So it's sustainable and renewable. So that's one major advantage. Number 1, fermentation uses a sustainable and renewable resource. That'll do. And then the second comes from the sort of conditions and the whole process that we need here. So we've got a comparatively very low temperature when we're thinking about other reactions. We've got 300 degrees for the hydration of ethene, so a lot higher than 35. Also, we can do this at normal pressure, so we don't need to increase the pressure to anything more than atmospheric pressure. Whereas, again, direct hydration of ethene, we've got about 60 atmospheres of pressure, so 60 times the pressure that we can do fermentation at. Our yeast is again a natural sustainable catalyst, whereas for the direct hydration of ethene, we would be using phosphoric acid. Lots of benefits of doing fermentation. Process is a lot nicer, a lot simpler. the conditions are not as harsh either. And sadly, that's really the only other benefit of fermentation, because there's quite a lot of disadvantages of fermentation, which is why the direct hydration of ethene is still so popular. Fermentation is a much simpler process which uses much less harsh and expensive conditions. Just in case it would ask you about the disadvantages, one, we can only make ethanol via fermentation in what we call a batch process, because when you make a certain amount of ethanol, when we get to a concentration of about 15%, that then starts to kill the yeast enzymes. So then we have to stop the reaction, kind of separate out the yeast enzymes from the ethanol, set it all up again, and then restart. And that's not very efficient or cost effective. Whereas when we are hydrating ethene, we can use steam instead of water, so they're both gases, and we can continuously pump gases in and continuously make the ethanol, so we don't have to stop and start the system. Another disadvantage of fermentation is that the glucose at the beginning is an aqueous solution of glucose, so the ethanol we make at the end will also be an aqueous mix of water and ethanol. So then we have to separate the ethanol and the water using fractional distillation, which is another process which we have to do, and also will use sort of a lot of energy demands, which probably leads to burning of fossil fuels, and so on and so forth. So that isn't great, whereas direct hydration of ethene produces pure ethanol, so we don't then have to do any purification afterwards. Anyways, to continue with our question, write an equation for the production of ethanol via fermentation. So we're starting with our glucose. There would be nothing else that we would need to write as a reactant, because the yeast enzymes are our catalyst. There's no oxygen because we're doing it in the absence of air. Now we need to know the formula for ethanol. There's a couple of different ways we could write it. I'm a big believer of structural formula, so CH3CH2OH. Some people would be happy writing C2H5OH. I think the key thing is we have to have the OH separate to all the other atoms, because that shows the functional group of our alcohol, and with organic compounds kind of after your alkanes and alkenes, we have to use structural formula, or at least keep the functional group separate so that we know what type of compound it is. So either C2H5OH or CH3CH2OH for our ethanol. And we also make some CO2. And in order to balance that, we need to make 2 lots of ethanol, which will give me 4 carbons and 2 oxygens, and now my 12 hydrogens. And then I'm going to need 2 CO2 so that I balance my carbons, 1, 2, 3, 4, 5, 6, with the 6 here, and my oxygens as well, 2, 4, 5, 6, 6. Perfect. So that's my equation for fermentation. And then when we're thinking about the combustion of ethanol, again, I'm going to use the structural formula, but again, you can use C2H5O, that's supposed to be a H. When we are doing complete combustion, we're going to need oxygen, and our 2 products are going to be carbon dioxide and water, because it is complete combustion. And when it comes to balancing combustion equations, start with either your carbon or your hydrogen, doesn't matter so long as you do those 2 first, and then move on to your oxygens last. And I say that because both of the products have oxygen in them. So if you only balanced the carbons and then did the oxygens and then did the hydrogens last, you would end up having to redo your oxygens because you'd then change the amount of oxygens in the water, for example. So we've got 2 carbons in ethanol. So I'm going to need to make 2 CO2. I've got 1, 2, 3, 4, 5, 6 hydrogens. So I'm going to need 3 waters. And then that gives me in total on the right hand side 1, 2, 3, 4 plus 3 is 7 oxygens. Now, because this is ethanol, not a hydrocarbon, we've got to remember that we've got that oxygen there. So we need to make 7 in total. We've got 1 there, so this needs to give us 6. So that's going to be 3. 6 plus 1 is 7. 4 plus 3 is 7. 1, 2 carbons, 2 carbons, 3, 4, 5, 6. Hydrogens, 6 hydrogens. Job done. So again, it's an 8 marker, and I don't think it would be an 8 marker in today's sorts of questions, possibly 5 or 6. But here we're going to have the 2 conditions, talking about the temperature being too high or too low, the advantages of fermentation, probably 1 for each equation as well. So 1, 2, 3, 4, 5, 6, 7, 8. Hopefully those 8 points are clear and you're happy, and I haven't said anything ridiculous in this video. But if anything that I've said is unclear, you want to clarify anything, you want to ask me something related to this question, anything at all, please just leave a comment on the video, or you can drop me an email to missgtutoringandresources@outlook.com. Thank you so much for watching, guys. I hope you have a really lovely day.